Hi there. I want to read this to you. This is from the RSOE. Environmental pollution in the USA on June 27, 2016. A spokesman for the Nuclear Regulatory Commission says a sheen on Lake Ontario has been traced to a small oil spill from the Fitzpatrick nuclear power plant in New York. This is a picture of the Fitzpatrick power plant. It's beautiful, isn't it? All nice and clean. Your safe and secure source of power. Here's the history. The James A. Fitzpatrick nuclear plant has been a safe, clean, and affordable source of electricity for New York since 1975. That's quite a few years ago, don't you think? All right. Also, this is kind of interesting. Every year we light up the sky at the annual Oswego Harbor Fest through our sponsoring of the Entergy Nuclear Fireworks Spectacular. Well, it sounds like they were about possibly ready to have another nuclear fireworks. Okay, let's read on here. The U.S. Coast Guard responded Sunday to a report of a sheen near the plant in Scriba, about 40 miles north of Syracuse. Neil Sheehan of the NRC tells the Rochester Democratic and Chronicle, blah, 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 that plant operator Entergy Corporation found the source of the oil on the roof of a turbine building. Sheehan says it appears that 20 to 30 gallons of oil leaked from a vent for the hydrogen seal system and entered the lake through a discharge drain. Sheehan says the plant operations weren't affected, and Entergy has taken steps to prevent any further discharges. Okay, so then I became curious about what is a vent for the hydrogen seal system. So I found this article, Power Engineering, and on here they talk about hydrogen cools well, but safety is critical. So this is saying that in its pure state, hydrogen is fine, but a mixture of air and hydrogen can be explosive. Then why hydrogen? By Nancy Spring, senior editor. Operating an electric power generator produces large amounts of heat that must be removed to maintain efficiency. Air, water, and oil all have been used for cooling, but hydrogen's low density, high specific heat and thermal conductivity make it a superior coolant for this application. Plus, it's abundant and therefore relatively inexpensive. The problem is hydrogen can be dangerous. In its pure state, hydrogen is fine, but a mixture of air and hydrogen can be explosive. So why hydrogen? Okay, so we just read that. Okay. Hydrogen is an effective way to cool the generator and allows power plant operators to get a lot more megawatts out of a smaller generator. So then this link will be down below and you can read it. Hydrogen in a pure state is fine, but when mixed with air, it becomes combustible. What makes it especially dangerous is that the explosive range of hydrogen in air is broad, from concentrations that range from 4% to 74%. Any mixture in that range is explosive. Not only does hydrogen have a wide flammability range, ignition takes little energy, said Stephen Phillips. Mixed systems produce line manager for Sensodyne LP hydrogen burns with a pale blue, almost invisible flame that can seriously injure personnel as well as cause serious equipment damage. A common method of detecting a hydrogen fire is to use a broom to sweep the suspected area. Making hydrogen stay put is almost impossible too because it is light and molecules are small. It is difficult to seal hydrogen, so there is a high probability you will have leaks. All hydrogen-cooled generators leak and have an acceptable leakage rate. Okay, so this says that when it does leak, it dissipates quickly, so it's relatively safe. Hydrogen can also build up in the oil that is used to seal it in the generator. Then the oil hydrogen mixture becomes explosive. Okay. So now this article from Star Tribune says the U.S. Coast Guard observed the sheen on Sunday. This is all talking about the same thing. An official from Operator Entergy Corporation said Monday that the oil came from a tank that overfilled because of an equipment malfunction. A Nuclear Regulatory Commission spokesman said it appeared 20 to 30 gallons of oil entered the lake through a drain. A little bit different story there. But, so if it's, this sounds so nice, like it's no big deal. But then I have to ask, an NRC report says the reactor has been shut down since a loss of power to the water pumps forced a manual shutdown Friday. So, that isn't really explaining anything, is it? Okay, now this article on WXXI News says the mystery of an oil sheen on Lake Ontario near Oswego has been solved. It turns out to be oil from the turbine building roof at that power plant. Official says the oil was coming from a vent for the hydrogen seal system. So here's a patent. Automated seal oil bypass system for hydrogen-cooled generators. US 7913815B2. And the inventor is this person, who I can't pronounce his name, and 5 more. And these people. Since I can't pronounce one's name, I'm not going to pronounce all of them, just out of respect. Original assignee is the General Electric Company. So, disclosed is a solution to automate a seal float trap bypass for a hydrogen-cooled generator. An automated bypass system is coupled to an existing manual bypass system for a float trap for a hydrogen-cooled generator. The automated bypass system includes at least one solenoid valve and a controller that controls opening and closing of the solenoid valve. The automated bypass system can also include manual valves, orifices, and limit switches. The controller activates the solenoid valve to allow the seal oil to drain. The controller, I don't think they're talking about a person here. I think they're talking about like computer generated thing here, the controller, can also provide a notification alarm that the hydrogen-cooled generator is being purged. Here's a description, here's the claims telling what it does. Here's the pictures of how it's made. Generator, seal, oil drain, enlargement tank, float trap, storage tank, controller, notification alarm, limit switch. Okay, there's one picture. This one's sideways, I'm sorry. Oh, here, I can rotate it. Okay, seal, oil drain, enlargement tank. Okay, another seal oil control unit. Generator, seal, oil drain, enlargement tank, float trap, storage tank, and we have all these valves here. limit switch, controller, notification alarm, storage tank, float trap, seal oil drain, enlargement tank, 4 of 4. And this is just making it larger. That's what we've already seen. Okay, so supposedly this is talking about how it would work and seal it well. At first aspect of the present invention provides a system comprising a hydrogen-cooled generator including a rotor, a casing enclosing the rotor, a seal assembly between the rotor and the casing, wherein the seal assembly includes seal oil, and a manual bypass system. Coupled to the generator, the manual bypass system, including a set of piping, a drain opening in the set of piping, configured to allow the seal oil to drain through the drain opening. Ah, if I memorized that and just said that to somebody on the street, that'd be funny, wouldn't it? A manual valve operatively connected in parallel with a set of piping controlling draining of the seal oil through the drain opening, and an automated bypass system coupled to the manual bypass system. The automated bypass system, including a solenoid valve, operatively connected to the set of piping to allow the seal oil to bypass the manual valve and drain through the drain opening, and a controller to control opening and closing of the solenoid valve. Okay, I'm just going to read for a couple seconds here more. A second aspect of the present invention provides a system comprising a manual bypass system coupled to a hydrogen-cooled generator. The manual and bypass system, including a set of piping connected to the hydrogen-cooled generator, configured to allow seal oil to drain from a seal oil assembly that is coupled to the hydrogen-cooled generator. To allow it to. Okay, so the link for this will be. So I want to also show you Lake Ontario here, which is where this nuclear plant is by. It's right over here. If you're coming from the west to the east, it's the last Great Lake. If you're coming from the east, it's the first one. And this picture is a very beautiful picture. My time is sort of running out, so I want to get down here to show you. By the way, the geology of all this is very cool, and the history of it. Let's keep going. Ecology and environmental concerns. The Great Lakes watershed is a region of high biodiversity, and Lake Ontario is important for its diversity of birds, fish, reptiles, amphibians, and plants. Many of these special species are associated with shorelines, particularly sand dunes, lagoons, and wetlands. The importance of wetlands to the lake has been appreciated, and many of the larger wetlands have protected status. However, these wetlands are changing in part because of the natural water level fluctuations have been reduced. Many wetlands are dependent upon low water levels to reproduce. Okay, so what they start talking about is, these amazing forests dominated by maple, oak, beech, ash, and basswood. They're talking about the plants and animals. Deforestation in the vicinity of the lake has many negative impacts, including loss of forest birds, extinction of native salmon, and increased amounts of sediment flowing into the lake. In some areas, more than 90% of the forest cover has been removed and replaced by agriculture. So, if you read all this, it's actually very sad. And then down here, my time is going. The food web has been damaged not only by overfishing and the changes in nutrient levels, but also by other types polluted from industrial chemicals, agricultural fertilizer, untreated sewage, phosphates, such as laundry detergent chemicals. Some of the pollutant chemicals have been found in the lake include DDT, benzoprene, and other pesticides, PCBs, amorite, chromium, lead, Mirex, mercury, and carbon tetrachloride. Okay, Fukushima was a hydrogen explosion.